Okay guys, what is OSI? Open System Interconnect. Okay, Open System. This was why it is called a Open System Interconnect? Because there is several different networking models are there, like a TCP IP model is there, SPX, Apple Talk, IPX, kind of different networking models from different organizations. Okay, so to understand any kind of networking model, so we can use this OSI model. Okay, so OSI is nothing but a network or networking model. How devices are connected, how devices can able to communicate, how they will share information, all these things we can understand from the OSI model. What are the model here? It is a reference model. Reference model means no one use any organization, no organization use OSI model. But why should we learn? We should learn. It is used for understand or to create new network. You want to create a new network to understand the network, okay, and troubleshoot, maintain the network, troubleshoot the network. So it is a 7-layer model. This is 7-layer model. 7 layers are in this model. It is standardized by ISO. It is standardized by ISO. ISO means International Organization for Standardization. International Organization for Standardization. Okay. So standard model. You should not say standard model. It is. This is the model where anywhere we can able to use it for understanding how network is functioning. Okay. How to create a new network. How to troubleshoot a network. Any kind of model we can use. Different networking models are there. So 7 layers are there now. It is having a 7 layers. 7-layer model. Why? Because it contains a 7 layers. So I'm writing a layer wise. Layer 7 is application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Okay, Abhishek in.
Sir, my attendance also, please mark the attendance. Faizan.
Faizan. Okay.
Yes, sir. Thank you, sir.
Okay. So we have a 7 layers. Some people already learn some networking related from textbooks as a college curriculum. So then they will go with certain textbooks or lectures, certain websites. Okay, shows in a different order, means reverse order, not different order, actually reverse order. Okay, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Which one is correct? So I given application layer, presentation layer, session layer, transport, network, data link, and physical layer. Which layer is correct form? Both are correct, guys. Both are correct. So do not think like a this is correct and reverse is correct. It's not like that. But do not interchange the layers. Do not interchange the layers. Okay. So application layer, physical layer, transport layer, session layer, then presentation layer, like that. Do not interchange like that. Either you follow 7 to 1 or 1 to 7. What is this 1 to 7 or 7 to 1? It is a layer number. The first layer is physical layer, second layer is data link layer, third layer is network layer, fourth layer is transport layer, fifth layer is session layer, sixth is present, and seventh is application layer or application to physical layer. You can take it. Okay, only layer order it is. So why we should write from application to present physical or physical to application? There is a reason. You want to send you have a system, think like this. This is A, this is B. Okay, two devices are connected in the network. So this is APCPP. I'm sending means first one is application layer. Okay, and next one is the last one is physical layer while I'm sending. In this side receiving, right? Physical layer, application layer. The first one is physical layer. So physical to physical connectivity is there, no? So obviously physical layer. So last here physical layer is starting here. While A to B. Again B to A. Application layer, physical layer, application layer. Okay. So while you are sending application layer to physical layer, while you are receiving physical layer to application layer. Okay, so that's why both are correct. Okay, both are correct. So I will explain from application layer to physical layer only, one by one layer. I will explain how to remember 7 layers. Already yesterday I given an IP address list: class A, class B, class C, class D, class E, and then I given sub default subnet mask like that. And now I'm telling about a OSI model, and there is so many things also there. How to remember, guys? Very simple. Keep reading, keep telling, keep thinking about it, so you will remember about it. It will take time. It's not like a one time you hear, you will tell immediately. It won't happen. So you have to keep telling. If I'm in a physical classroom, I will I will make people to speak, tell by everyone one by one. Now it is very difficult. I have to spend another 2 hours for completing everyone. Okay, so we don't go to that much depth. Okay. First one is application layer, guys, but yeah, here it is. Application layer as a part of application layer, and it's another important thing in a networking is the protocols. The protocols. What is this protocols? Protocols are, as per a textbook and as per our college lecture, is a set of rules. Of course, it is a set of rules. Means what rules? What rules? Okay, it is defined what kind of communication you are doing. what type of communication, what type of connectivity you want it. So that is defined by your protocols only. Okay. Protocols are a set of rules to understand what is the request and what is the response from client to server, server to client. So client will send a request to the server. So the server understand what is your request. How server understand? Based on the protocols. Protocols defines what type of communication it is. Is it a web related communication? Is a file upload download communication? Is a mail communication? Time synchronization, authentication, remote access? Okay, what type of communication it is? So that is a protocols. Okay. Here I given an example, HTTP protocol. If you look at here, it is HTTP, HTTPS protocol. You can see this is also HTTP, HTTPS protocol. It is a web page related communication. I want to access my remote PC web page, so HTTPS protocol. Okay, so that is there is a web server. I'm requesting HTTP, so it will provide HTTP response, means web related communication. I have a remote server. It's a file server. I want to upload and download files from the server. Then I use FTP protocol. I have a mail server is there. I want to send a mail or I want to receive a mail. I use SMTP, POP3, IMAP kind of protocols. Network time protocol. So if you see this one, this is my time. This time and date is came from the time server. I'll show you that one. Adjust date and time. You can see the time server is time.windows.com. From this server, based on my time zone, I got this date and time. So it is continuously synchronized with that one. LDAP, care browse, or authentication means when you log in, someone has to be verify username and password, right? Authentication protocols. Remote access purpose, SSH, TELNET, RDP, remote access purpose. Like this, each protocol has a particular service related, and server and client understand what type of communication it is. Okay. Yeah, this small diagram is also there. So no problem, we'll put it. Okay. Think like this. This is PCA. This kind of server. Example, it is a web server. I want to access the web pages. So what I will do? Of course, we need a IP address, but also we need a protocol. So I send a request to the web server. I'm sending request, HTTP request. So web server understand you're asking for a web page. Okay, web server understand you're asking for a web page. And web server is give response to you. HTTP response. For example, you're sending some other protocol. It is a web server, right? It is a web server, but you're sending a SMTP request. So it's not a mail server. SMTP request you have to send to mail server, but you are sending to a web server. So what web server will do? You don't understand what is your protocol. It's not the server. It will drop the packet. It's okay. One second, guys. What happened to you guys? Don't send personal messages. You are in a classroom, then you can tell in a classroom. So why personal messages? Shiva. Okay. So this is I can reduce it if you can want. You can reduce it. Guys, I'm giving certain protocols. There's some small description and their port numbers. Protocols are, for our understanding, it is there, but computer process the protocol information in the port number manner only. Okay. So this is each protocol has certain port number. Okay. Most certain protocols and their port numbers are reserved port numbers. It means this protocol you are using and this is the port number. It may changes only if it is over SSL. Means these are reserved port number for these protocols. Not only these guys, there is a 1023 protocols are there and 1023 port numbers are there. There's several port numbers and protocols. So which one I'm giving only some top list of protocols and their port numbers only. Certain regularly used protocols that details only. Here, one of the important question and always in interview is HTTP, HTTPS difference. HTTP, HTTPS both are web access related. HTTP and HTTPS both are web access related, web page related, website access related protocols. Okay. HTTP port number is 80, HTTPS is 443. What is the difference between HTTP and HTTPS? HTTP over SSL. HTTPS, S means like a secure. Okay, secure means it's over SSL. Data is encrypted. See, my data is there. I can able to see the data. When you are accessing, you can able to see the data. But while transmitting the data through the network, data is encrypted. Okay, what are the data you are sending and receiving through HTTPS protocol? Data is encrypted. HTTP data is not encrypted. So encrypted data is difficult to understand, difficult to crack it. Like your WhatsApp, end-to-end encryption means you can see the data in your mobile. The recipient, the other person can able to see the data in his mobile phone. But while you're sending and receiving a data is in the encrypted format. Okay. FTP, file transfer protocol. You want to upload a data or download a data. So we use FTP protocol. SSH, port number 22. For remote access purpose, I want to access my remote Linux machine, I want to access SSH protocol and SSH secure shell, and it is secure, so it is encrypted. So you are connecting to remote device or remote server and you are transmitting data and receiving a data. So that is in the form of encrypted. Telnet is also remote access, same as SSH, but Telnet do not encrypt any data. Okay. RDP, remote desktop protocol. You have a remote Windows type of machines, Windows server, Windows client machine, it is there. Okay.
Sir, repeat telnet again.
Telnet, a remote access. For example, I will show you one thing. So that's why morning I started this virtual machine. N19. I have a remote machine. 94.183. So I'm accessing with SSH because my remote server is SSH. You cannot telnet. Okay, so I'm showing SSH, so you will understand what is remote access. Port number is 22, SSH protocol. This is my remote machine. Open. Yes. This is my remote machine. I'm logging with the root account. And also SAR is also accessing one of our time. admin@123. I'm going to some chain settings, appearance. So you can see this is a remote Linux machine. I'm accessing with a SSH protocol. I'm accessing with a SSH protocol. Remote machine it is. Okay. In my desktop, I don't have currently I didn't open any Linux machine, right? It is remotely, it is in the network. I'm accessing from here. This is a PuTTY application. Application name is PuTTY and the protocol I use SSH. Same way, if it is the Telnet is installed in the remote machine, I can access through Telnet also. This is SSH, encryption is there. Whatever the data I am accessing, I am connecting, sending, receiving, entire data is encrypted. Okay. If I am using Telnet, data is not encrypted. Guys, understand remote access. Okay. Another one is RDP. Telnet and SSH both are text-based remote access, means command line interface only. Okay, command line interface only. RDP is not command line type. It is a GUI type, means entire desktop environment you can able to access. So this is my desktop. If someone want to control my desktop, someone want to access my desktop, so they can access entire desktop environment. Okay, so remote desktop protocol, RDP. Okay, so for example, I have a remote Windows server is there, remote Windows 10 machine is there. I want to access from my PC. I can access it. SMTP protocol, simple mail transmission protocol. So it is used to send mails. I want to send a mail to my mail server. So I use a protocol, SMTP protocol. To receive a mail, so you want to retrieve your mail from your mail server, like that is POP3 or IMAP, any one of the protocol, we are using it. TFTP, trivial file transfer protocol. TFTP, trivial file transfer protocol. Okay, what is trivial file transfer protocol? So it is to upload or download or backup the remote configuration files. For example, I have a remote server or a remote router or a switch. I want to upload a configuration file or download a configuration file or a backup the configuration file. I use TFTP, Trivial File Transfer Protocol. DHCP, Dynamic Host Configuration Protocol. So you want to, you are getting an IP address from DHCP server to your mobile phone or laptop. So instead of manually configure an IP address, so you are getting an IP address from DHCP server. Okay. DNS server. What is DNS server? Domain name server it is. Domain name system. You open a google.com, facebook.com, youtube.com. You are open with the names, but actually all communication with the IP address only. I open this thing with an IP address, right? With I given first IP address, then it is open. Because in my place I don't have separate DNS server, so I can't communicate with the names. You are not communicating. You or me, we can't communicate with the names. We should communicate with the IP address only. But do you know Facebook.com IP address, YouTube.com IP address, Google.com IP address? You don't know, no? So then system send a request to the DNS server to get an IP address of these servers. NTP, Network Time Protocol. Okay, Network Time Protocol already I showed. I got an IP address from time.windows.com. Okay, so there is a NTP servers. So whenever you want to get configured from NTP, so you have to send a request time related. So then you will get a sync with their time. Kerberos. Kerberos is an authentication protocol. LDAP authentication protocols. Kerberos authentication protocol mostly used in a Microsoft Active Directory. Kerberos authentication protocol used in a Microsoft Active Directory. LDAP is a more open, so Unix, Windows, Linux operating system use LDAP type of protocol. SNMP, Simple Network Management Protocol, usually used in a monitoring purpose. Okay, you have a lot of devices in your network infrastructure in organization like a servers, routers, switches. To monitor those things, we use SNMP protocol. Okay, so this is the point. So yes, this is the protocols and some protocols and port numbers. Still you want to add some more protocols, you can add it. For example, you take MySQL, okay, 3306 by default. Okay, you take Oracle. In Oracle, there is a service Oracle database related TNS listener 1521. Just for small point, that is Tomcat 8080. Tomcat is a web server and as well as an application server, a small size application server. Okay. It's not like that, so it's a compulsory 8080 kind of stuff. Generally, Tomcat port number is 88. Okay, it's not stable. Okay, it is stable, means reserved. It's not reserved. The different type of services can use 8080 port number, but mostly web related. Guys, this is about your protocols and port numbers. So I told about a OSI model and protocols and their port numbers. Okay. So if you think happy completed, no. Each one explanation is there. This transport layer called a heart of OSI model. It provides a end-to-end connectivity. And of course, there are some other duties that we will discuss. So we given a physical layer example, that is hub. Data link layer example is switch. Already we learned that one. Network layer example is router. These are all hardware devices, right? That's why these three layers, we called it as a hardware layers. And these are called bottom layers. Not top layers, it is bottom layers. Mainly it is hardware layers. These three layers are called top layers or upper layers, and mainly software layers. These are software layers. These are the top layers or upper layers. So layer 1, layer 2, layer 3 are hardware layers. Layer 5, layer 6, layer 7 are software layers. Transport is the art of OSI, end-to-end connectivity kind of stuff. In which ways we have to start with the application layer. As a part of application, one part I completed, that is protocols and port numbers, but remaining we'll see. Application layer is dealing with the application part of your network. You want to send a mail. Yeah, what is this? Got it. You want to send a mail, maybe use a web browser, maybe use a Outlook kind of applications, right? You want to access a website. What you use? A web browser. You want to access, just I use an application, PuTTY application to access my remote server with SSH protocol. So I want to access a website with HTTP protocol. So this is my remote web server, and I use a HTTP protocol. So can you see website data is also visible. Test page. Just afternoon only I created this small page. Okay, it's my remote web server. Remote web server. So I'm accessing website using a web browser. Okay, so that side it is Apache HTTPD service is installed. A package is installed there. Okay, guys, application layer dealing with client and server side applications, protocols, and port numbers. Client side applications like a web browser, Outlook, PuTTY, FileZilla. So FileZilla, it is an application actually used to connect remote FTP servers. To connect remote FTP servers to upload data and download the data. RDP, so you take MSTSC, Microsoft Terminal Server Connectivity. So this is my client-side application to connect remote remote desktop server. Okay, so it's a client side, and server side applications like a web server. Web server, how a server become a web server? By installing some packages or application, like installing Tomcat application, HTTPD packages, roles like a Microsoft Internet Information Services. Mail servers, example, you install a Microsoft Exchange application, it is a mail server. Install a Zimbra application, it is a mail server. You install Squirrel Mail application, it's become mail server. Okay, so server side applications are there. Okay, so remote SSH servers, telnet servers, FTP servers, remote desktop servers. So those are a server side applications, server side, client side applications. And guys, I use HTTP protocol in web browser. In this one, I use SSH protocol. I will tell you one more, that is command prompt. I am using simple ping command. Same system, same computer. I am getting different type of outputs from same server. Like this. I'm using ping command. Ping is ICMP protocol. Ping is use ICMP protocol. Web browser HTTP protocol. SSH wise also connected. So which protocol, which application I used in the client side, and server is responding based on your protocol. I'm using ping command here. I'm not getting web page. I'm using HTTP protocol. I'm getting HTTP response only, not a SSH kind of link, right? So which protocol I'm using and where I'm using and what I'm getting. Okay, this is what application layer will do. Got the point, guys? Of course, it's not a mail server. Any other services are not there. Yeah, you can try telnet, same machine, 172, 16, 194, 183. Try to connect, sending a telnet request to the server. If server is a telnet server, what I will get it? I will get, yeah, I'm just, it will ask connectivity, username, password. It's not a telnet server. It's not a telnet server. It will fail to connect. I want to connect with SSH. My remote server is SSH server. Then I will getting a connectivity. So it is asking, you want to connect? Send present yes, and it will ask for a password. Give the password. No, it's not password for user. Okay, that's wrong kind of stuff. Yeah, we'll view password, but it won't work. User is different. Want to connect with root user. Okay, so that's the point, guys. So here also I'm cutting. You can see this is my Linux PC now. The dot that's won't recognize that command also because it's a Windows terminal. This is Linux terminal. This is Linux. This is Windows. Okay, so point is, guys, what is an application layer? Server side, client side applications, protocols, and port numbers. So how server understand what is your request by the protocols, and any the protocols use in a some place. I use as telnet and SSH in PuTTY application, and same I can able to use in the command prompt also. Possibility is there, so I used it. Okay, working or not working later, and also use ping command. But this is a web browser. In web browser we don't use it. Web browser we use HTTP, HTTPS, FTP type of protocols. So application protocols and server services. So these are comes under application. So guys, understand anything?
Yes, sir.
These two are very easy, simple points only. And next transport layer is a bigger one. Next two layers are again smaller one only. Next one is a presentation layer. Presentation layer encode the data. Presentation layer encoding and decoding data. So here having a data, the data is in a normal any different format, right? It can be a text format like this or HTML format like this. I open something. This is a HTML format can be there, or it can be picture formats. You have a pictures in this one. Okay, you have a pictures are there. So earlier also we have a lot of pictures. Picture format, video format. Okay, so PDF format. So data can be in a different formats. So this data is converted into ASCII format and ASCII format to binary format. Okay, so and the data will be compressed. Data is big in the size, that will be converted into, so that will be compressed. When you are sending, you will compress. When you are sending, you encode it and compress and encrypt the data. If you encrypt the data, data cannot be accessed by different people. Okay, so if you are using HTTPS, encrypt the data. You are using SSH protocol, encrypt the data. Okay, like that. Next one is session layer. Generally, session layer is we are telling in one single line, that is called create a session, maintain a session, terminate a session. Now guys, actually it is a big explanation is there for a session layer. Okay, and 2-3 things you have to keep in mind in a session layer. So this is my a device. So I'm not talking in a server and client type. So I'm sending a data. So I want to send a request, or I'm sending a data. I'm sending a request to this one. So then I will get a reply. So when I'm sending session, I will be created. In this session, I will add up all my information, what I want to send a request, whatever the data information, everything will be added here only. Okay, and it will create attached with a session ID. Then it will send. Once receiving end, see your request, your information, your data, okay, like your username, password. Okay, so you are want to connect. So when you are sending, this is my username, this is my password, authenticate and give me my data. Like you are login to Gmail account. First you give a username, password, then other side it verify username, password, it authenticate. Once authenticated, it will give you, based on your request, it will give you information. So I said you are accessing a Gmail or you are accessing these documents, you should get authenticated, right? First you are sending a request, and clients server side it will check who is the person is requesting. And what is requesting? What is the ID of request ID? Once it is you got authenticated, and it will give you information. Once you receive, then session is what is completed. Okay. So that's the point. It is of session layer. So we cannot write it completely, but I'm trying to explain it. For example, guys, I open a w3schools.com or java.t.point.com, some google.com. So this is also send a request, right? The request go to w3schools.com. I want to your page. I want this information. But this time I am not using any username, password, email ID. I'm not using. Send a simple request. I'm getting this information. Or maybe I want to read about something tutorial. So Python is the best one always. Okay. So I send a request. I want this particular page. So server give page, but I didn't give any username and password. So I'm asking anonymous. User is anonymous. So is he allowed to access this content? Yes. Then it give the content. Okay. So that is your session layer, guys. So in the session layer, your request when from client, it is request with a session ID and information, authentication information, who is asking, what is he asking, everything in this one. So once it is reaches the server, server verifies your authentication and delivers information. So then you will get it. Okay. So that is one point in the session layer. It maintain the session, create a session, maintain the session, and terminate the session. One session is completed. One more example I will give you guys, that is when you do Amazon, Flipkart or anything, just you are doing a payment time. So mainly payment time. You given your card details, okay, OTP details completed, right? So once you go next, it will tell you do not refresh or press the back button. I remember guys, when you do any transaction, you're buying something from online kind of stuff, do not refresh or do not press the back button. Are you submitting some application, online application you are done? So do not refresh or don't press the back button. White shows if you refresh, it become another session. Your current session will be terminated, another session will be created. So your server means how it is happens. So we'll take Amazon as an example. So you are buying an item. Your request go to Amazon. Amazon will give you all item list, price list to you, right? So you are getting that price list and you click on buy now. So Amazon will go to the payment option. It will give you the payment screen. So you are giving details of your card, then send to the Amazon. Amazon is verified with the bank. Send verification with the bank. So bank is check your details and okay, then payment is done. The payment sent to the Amazon. Okay, once Amazon approved the payment, means bank transaction to Amazon, Amazon approved, and it will send to you amount is transfer and successfully placed. So this thing happened, right? This thing should be happens. So now what happened? You send a request to the Amazon. You send a request to the Amazon. Meantime, you refresh the page. It taking time, you refresh the page. Money went to it will send a verification with the bank. Bank verify your identity and it cut the amount and put it into Amazon. But Amazon, you refresh it now. This session is already done, completed, or it is gone. Okay, the transaction is happened, but Amazon don't receive, do not able to attach your transaction there. So what it say it is transaction failure. amount is detected. Okay, so you will be like based on that logs. So there is several logs will happen, right? So based on that log, automatically bank verifies. So transaction is completed or failed at a client side or at another server side. So it will return the money within the one day or 1 week kind of stuff. Sometimes immediately. Okay, that's why do not refresh our back button. If you do it, so the another session will be created, your session will be terminated. So your transaction in middle somewhere, it may be completed, may not be completed. Okay guys, this is about a session layer. Okay, to write in a session layer, so we are not doing much thing, but it is very good one. Okay, we can't type everything, try to understand. Guys, understand what is session layer?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
So next one is transport layer. Transport layer contains so much of information. We'll see about a transport layer. Okay. What is transport layer do? It provide end-to-end connectivity. It provide end-to-end connectivity. Okay. And it segment the data. It chop the data into small pieces. You can see it is, for example, I have a data. This is for example purpose only, guys. It's not exactly what happened like this. I have a data. For example, it chop the data into small pieces. Each piece is must be around more than 64 bytes to maximum size is minimum size is 64 bytes, maximum size is 1500 bytes. It should chop the data into small pieces depends upon the data sizes. And it put in a numbering on it. Next one is numbering and sequence. It puts some number on it. Okay, so what are the pieces are there? They put a pieces part. Because entire data you are sending, so while transmitting data may be corrupted. So again you have to send the data again. So what happened? So one large content is difficult to transmit. Nowadays, I purchased last time a chapel stand, like a shoe stand it is. Another one is like a grocery stand. Another one is wardrobe. Okay, so all are assembled, deassembly, all are parts only. Okay, so what I have done, I have to assemble it again. I have to assemble it again. Okay, if one part is missing, I have to reorder that part. If it is single unit, it's very difficult to carry. Lot of transport related. Again, I have to change my house. Okay, so I purchase in Pune, now I have to transfer to Hyderabad. It's very difficult to transfer. Okay, so that's the point. It will chop the data and make it as a pieces, and then it's numbering and sequence. Okay, if in case it is transmitting data, guys, for example, this is my source, this is the destination. I'm transmitting a data. First packet is sent. Okay, and the first packet is received. Once destination received, it give acknowledgement. I received it. Second packet sent. Third packet sent. Fourth packet is sent. Second packet is received and it will give acknowledgement. Third packet is not received no acknowledgement. Fourth packet received, acknowledgement is there. So server received means sender received first packet acknowledgements, second packet acknowledgement, fourth packet acknowledgement, third packet acknowledgement not received. So server means APC thing, it received hello, this first packet, this packet, and this packet, right? So this part is not received. So what it will do? It send it again. It will send again. Now it is received. So then acknowledgement. Third is received. So what happened? Now the data is not in the proper order, right? This is hello, how are you? This is hello, how you are. Okay. So it is not in a proper order. So again, it will rearrange the data because of numbering. This is 1, 2, 4, 3. Again, it will rearrange the data. 1, 2, 3, 4. So this is, we call it as a error correction. Error detection, error correction. This any error is happen at a receiving end. Okay, so it will try to correct it. So error detection, error correction. And transport layer also do multiplexing and demultiplexing of protocols into TCP and UDP. Okay guys, look at here. I have showed some protocols, right? These are the certain protocols and their port numbers, right? These protocols are TCP type protocols are there, UDP type protocols are there. TCP type protocols and UDP type protocols. TCP type protocols having certain kind of behavior and UDP type protocols, the behavior is different. TCP transmission control protocol, UDP data user datagram protocol. Transmission control protocol, user datagram protocol. Transmission control protocol, user datagram protocol. TCP is an acknowledgement based protocol. UDP, there is no acknowledgement. Okay. Meaning is you send a packet to destination, destination received a packet, and it will send acknowledgement to the source. So source knows destination received a packet. Of course, there is a one more type of explanation is there. This is only we are concentrating on simple one. Okay, so we'll tell. Okay, source knows destination is received. How? So destination received a packet, it will give the acknowledgement to the source. If destination not received a packet, it does not send any kind of acknowledgement. The source thing, source don't receive, if source do not receive acknowledgement for the packet, so source thing, destination is not received a packet. So I'm the source, I didn't receive an acknowledgement from my destination. What I think? Destination is not received. Okay, so what source will do? It will send it again. Source what it will do? It send it again. So this is a TCP type of protocols. Like example, HTTP protocol, SMTP protocol, FTP protocol. These are all TCP type protocols. Their behavior is acknowledgement based. So source send a packet to destination. When destination received a packet, it will give an acknowledgement. So source knows destination is received or not. That's why TCP type protocols are called reliable protocols and connection oriented protocols. Guys, connection oriented, connectionless, it does not mean wired or wireless type of communication. Wi-Fi communication, it's not like that. It is not that related. Whether it is wired or wireless, protocol behavior is what we are discussing here. Okay, it's not about wired or wireless communication. Connection oriented means the destination is maintain the connectivity to the source using acknowledgement. Means source knows destination is received a packet. UDP, user datagram protocol. It's no acknowledgement. We don't use any acknowledgement. Source send a packet to destination. Destination received or not does not known by your source. So source don't know destination is received a packet or not. Okay. So that's the point. There's certain examples of the UDP. DHCP protocol, TFTP protocols are best example for UDP. DHCP protocol, TFTP protocol, UDP protocol, DNS protocol is both TCP and UDP. DNS, TCP and UDP, both are there. You want any explanation, then go to TCP UDP protocols with the DNS list of TCP UDP protocols. Go to list of TCP UDP protocols, then you can find what protocols are TCP type, what are UDP type protocols, and what are the both type protocols. You can get it. UDP is called a connectionless protocol. Connectionless means source don't know destination is received a packet or not. Source send a packet, destination received or maybe not received. Source don't know about it. That's it is a connectionless.
Sir,
Okay.
what you told in reliable and non-reliable?
Reliable means I will give you acknowledgement example. In olden days, when you write a letter, normal letters don't attach with acknowledgement, but any registered post, receipts, for example, you apply an online examination, the GATE examination, any set examination, government job, bank jobs. So you will receive an acknowledgement. So what you think? Yes, I am applied. This is the proof that other person, other organization received your application, received the payment. Okay. So example, UPI transaction, you are doing the phone pay kind of stuff, right? Paytm. So you will get a transaction successful. You are getting some acknowledgement that is payment is received. So that is a trusted one. What you trust that kind of stuff, right? So source send a packet, destination is received, and destination given acknowledgement. So those protocols are reliable means source knows destination is received. Okay, that's it is reliable.
Okay, sir. Thank you.
Non-reliable means you send a packet, then we don't know whether it is received or not. For example, I will design an application. Currently, I don't know any application with it. You scan a code and type the amount, transaction is completed. You don't know transaction is done or not, money cut is there or not, other person received or not. You don't know anything. Okay, that is a non-reliable platform, so we don't check it, right? Okay, next. Two, three more are there. Three are very simple. Not, no, sorry. I have done mistake. mistake is I explained TCP UDP, but I didn't explain remaining things. Flow control and windowing. Flow control and windowing. Guys, when you are sending a data, you may, or high speed data, you can able to send 10 packets at a time. 100 Mbps, we can able to send. But other side, he may not able to receive all packets at a time. Okay, it's not much speed. So then our transport layer map this flow control or windowing means it will send 10 packets to the source to destination. So it can able to receive 8 packets at a time. So 2 packets are dropped. Okay, then it will send only 8 packets next time. So 8 packets received means lesser dropping. I send 20 packets, 10 packets received means 10 droppage there. Again I have to send it. Instead of doing that one, estimate the capacity of receiving end. So based on that, you have to send a packet. So you have to control that flow. So you don't need to resend the packet again and again in case of packet drop is there. Okay. Receiving capacity also varies. How? Any guesses? Receiving capacity of a destination can be varies. Because I am sending, someone is also can be sending, another person is sending means full traffic data is here. Okay, so it depends upon the port busyness. So the transport layer estimate how many packets it can able to capture. So it will tell I am sending 10 packets. And receiver side, yes, I received 10 packets means no packet drop. I told one by one packet wise now. Originally it is won't happen like that. It is bunch of packets will send and bunch of acknowledgements we receive it. That's the point, right? Completed almost. We are in this line, guys. I told OSI model, 7-layer model, right? Each model. So you take application layer, presentation layer, or session layer, or transport layer. Each layer has a data. Regular data is there, protocol data is there, port number data is there, okay, encrypted data is there, encoded data is there, right? Data either data format or maybe encoded format, compressed or encrypted format. Okay, so the layer wise data, what is the layer data it is? If we call it as a data in the layer, whatever the format it is, data in the layer, we call it as a packet data unit. Whatever the data format, whatever the thing is, the OSI layer, each layer, whatever the data it is, we call that one as a packet data unit. Okay. TCP header is added to this PDU at transport layer. What is this TCP header? Header contains information about segmenting, numbering, sequence orders, TCP, UDP protocols, what protocols we are using, windowing information, okay, how many packets you are sending at a time. So that is also there. PDU, packet data unit. So finally we got an outcome of transport layer is segment. The data in the transport layer, the output of a transport layer data is segment. So this PDU from session layer, it is added with a TCP header. Then we call this PDU called a segment. Okay. This segment is sent to the network layer. So this is the network layer. Network layer is actually dealing with the two things. One is routed protocols, means logical address. Logical addressing, different type of logical addressing is there. What we are using is IP address. Of course, logical addresses are so many type of logical addresses are there. Okay, so we don't worry about other things. We are using IP addresses, either IPv4 or IPv6. Next, network layer also dealing with the routing protocols, means how to send a data, how to reach the destination, path selections. Okay, so these are all done by routing protocols. Different routing protocols are there like RIP, AGRP, OSPF, kind of stuff. Also default routing tables. So it is like path to reach the destination. That information, that is, it will add a path and it will add a source IP address and destination IP address to your segment. Okay, what is PDU you are getting from transport layer is segment. To that segment, network header is added. The network header is nothing but our source IP address and destination IP address. So this we call it as a packet. This we call it as a packet. The PDU from network layer is packet. The packet is sent to data link layer. Packet is sent to data link layer. Packet sent to data link layer. Data link layer actually dealing with two sublayers. The data link layer having two sublayers. One is LLC, another one is a MAC layer. One is LLC, another one is a MAC layer. Logical link control layer, which is dealing with WAN protocols. You are communicating outside of your network, means through WAN you are communicating, means you have to use WAN protocols. PPP, SDLC, frame relay, these are all WAN protocols to communicate over the WAN. Okay. Next is data link layer also dealing with the MAC addresses. Media access control. Okay. So we already discussed MAC, right? On NIC, we have a MAC address. Okay. So that MAC layer is dealing at data link layer. That's what it is. Switch is related to layer 2. Router is related to layer 3. Router dealing with the IP addresses and routing the packets, right?
Sir,
So
what is header and tail in the data?
what it is?
Sir, header and tail of data.
This one you are telling. Okay.
Yes, sir. Please tell something about header and tail also.
I will tell you. Okay. This is MAC. Okay, LLC, logical link control, dealing with the WAN protocols. If you are communicating through WAN, so they are using WAN protocols. What WAN protocols are you using? That will be added here. In generally, local LAN network we are. Okay. So it's a MAC address will be added. So MAC address is physical address, which is assigned by manufacturer of that NIC only. It is 48-bit represented in 12 hexadecimal. That is, we are already know, just I am repeating. You got a packet from network layer and it will be added with a data header and data tail. The header is, as a header, you will get source MAC address and destination MAC address. Source MAC address and destination MAC address. Okay, while you are sending that, so your MAC address and destination MAC address to your packet plus CRC as a data tail. Data tail. So what is data? Data link layer now. So that's the point. Okay, header and tail. In the data link layer, that's why we write data header, data tail. If it is a network header means network layer, network related information like IP address information we are adding. Here we are adding a MAC address, source MAC address, destination MAC address to your packet plus CRC, cyclic redundancy check. Cyclic redundancy check. What is CRC? It is a kind of algorithm to verify your data. Data may be corrupted, may be good. So how to confirm data is good or not? Based on CRC, cyclic redundancy check. So it's for error checking or error detection, not error correction. So it won't correct the error, it will detect the error detection or error checking. Okay, so this source MAC address, destination MAC address, packet plus CRC is become a frame. The PDU is frame and frame sent to physical layer. So why header and tail? This is the original information, right, from above. From here I am getting a packet. So from network layer I got a packet, and before the packet and after the packet. So that's a head and tail.
Yes, I got it. Thank you.
Got it? It's simple one only. Someone send a message. That encapsulation, don't go to that kind of stuff. It confuses you and me. Guys, next one is physical layer. Physical layer converts this frame, the frame from data link layer. Okay, it convert this frame into bit stream. Bit stream means zeros and ones only. Again, this bit stream convert into electrical signal or radio signal or a light wave signal based on what type of connectivity you are using. For example, you are using Ethernet type of communication and cables like a UTP, STP, electrical signals. You are using Wi-Fi kind of signals, like a Wi-Fi kind of connectivity, radio signals. You are using fiber optical channels type of connectivity, then light signals, light wave signals, right? So the physical layer converts your frame into bit stream, and the bit stream will be converted into different type of signals, electrical signal or can be radio signal or light wave signal. Okay. So guys, while you are communicating from, what I am doing, I copied, I pasted. This is not, data is not changing. Copy. So I plan to not to type, that's why I copy pasting. It's not listening to me. Now it is good. Give 12. The small size is important, that's why. So guys, this is my source PCA. I'm sending to PCB. The first layer is application layer. What type of communication? Are you sending a ping request? Are you sending a SSH request? Are you sending a HTTP request to the PCB? So that is at application layer. What application you are using to give a request or to send a data? What kind of application you are using? What protocol you are using? That is application layer. And the data, once you are done, so you've given a data request or a response from your side, the presentation layer encode the data and compress the data and encrypt the data if any encryption is applicable. Okay, And the session layer will add up all these things together. So what is the request and information about a source destination, authentication, like this. It will create a session ID and attach all your information there. Coming to the transport layer, this transport layer, what are the data? It is segmented, means chop the data into small class, numbering and sequence order, TCP, UDP, protocol multiplexing. Okay, all these things done in a transport layer. And what we are getting from transport layer is segment. The segment sent to the network layer. Network layer is add a source IP address and destination IP address to your segment. Then it is become packet. A packet sent to the data link layer. It is added with the source MAC address, destination MAC address, and CRC cyclic redundancy check to your packet. Then it is become frame. The frame sent to physical layer. Physical layer convert into bitstream to the connectivity based. For example, I am taking a simple LAN connectivity. It's an electrical signal and it is travel. So at a base destination, PCB, the physical layer receive your electrical signal. It convert electrical signal into frame. The frame is sent to the data link layer. At data link layer, it verifies the source MAC address and destination MAC address. Destination means this is belongs to same or not, same system MAC address or not. Okay, so same system MAC address or not. So I will add one more point here, guys. Okay, so don't mind about it. So here it is. Okay, while I'm sending. So at PCB, it received the source MAC address as A. So it received A's MAC address. It received A's MAC address and B's MAC address, and B's MAC address verify against BPC. If it is correct, accept the packet. And CRC. So it will verify any data correction is happening. Okay. Detect the data, any errors are there. Detection or a correction, it will do it. Next, once it is verified, then it will go to network layer. In network layer, there is a source IP address, destination IP address, and a segment. Right? Where is whose source IP? A's IP address. Then it will note down A's IP address. It note down BPC, note down A's IP address, and verify destination IP against the BPC IP address. Both are same, accept the packet. Both are not same, drop the packet. Next. So once at the network layer, IP address is completed. Okay, then we got a segment. The segment sent to the transport layer. So segment contains your protocol information, sequence numbering. So at the transport layer, the packets will be reconstructed, not at application, at transport layer. Finally, we received all the packets, one by one packets we are sending, right? So all packets will be assembled at a transport layer and it form an original data. It will be generated from transport layer. That data is sent to the session layer. Session layer understand what is the session ID it is, what kind of requests, what kind of protocols are there. Then session ID, give it to the presentation layer. Presentation layer, decrypt your data, decompress your data, and decode the data. So the data is now completely pure form of data it is. Give it to your application. Application verifies what kind of protocol and what kind of request you are sending, what is the thing. Okay, based on that, at application layer will decide what kind of reply or a response we have to send it. So then application layer get ready with the response, okay, and assemble the response, give it to presentation layer, again encoding, compress and encrypted, and it has attached to your session ID, means the old session ID only, same session ID. So it is attached that information and it will passes to transport, again segmenting, numbering, sequencing, TCP, UDP, multiplexing is happening. At network layer, it is reverse. Now source IP means BIP, destination IP address is APC IP address. So then to the your segment, then it is a packet. The packet sent to Datalink layer. Source MAC address means B's MAC address. Destination MAC address is A's MAC address, and CRC will be added. The okay, that is become a frame. The frame sent to physical layer and it convert into bit stream to electrical signal passes to this at a physical layer. Okay, so guys, while you are sending application to physical layer, while you are receiving physical layer to application layer. Do you understand this part, guys?
Yes,
Yes, sir.
Yes, sir.
Okay. So I am adding one command here because I am telling this one. Yet PCA received source MAC address and destination. So source MAC address and source IP means received an IP address, received a MAC address. So what this do it maps IP address to MAC address of the device. Okay, it maps IP address means a IP address and yes MAC address into the system. It create a table, mapping table. It is there. Okay, so that protocol we call it as a ARP protocol. Address resolution protocol. Address resolution protocol. Okay, what is address resolution protocol? It maps IP address, incoming IP address, like received IP address and received MAC address for same device. Address resolution. How to check what are the IP addresses you received and what is their MAC addresses? This command called ARP space -A. What is that command or where it is the command? This is the command I given and I will show you some outputs here. This use it to find a list of ARP responses. This is ours now. This is my system. Any other thing is I have two adapters I use. This is good one. Just for why I use this one, this is my interface IP address and this is my gateway, some IP address it is. This is not, yeah, my DNS server related machine it is, but I am removing those information, not required. Okay. Just I need only two information. Yeah, 59 is okay because that is also my PC. Yeah, 220, 240, I think I received a packet from there, maybe, may not be. Okay. Broadcast. These are also not required. I'll just remove these things. Okay, now it is good. Guys, I try to communicate with 183, right? This is 183. So when you done a transaction, either you send or you receive, either you send or receive. So you are sending a request means that will send back to you. Or someone requested to your PC means it will give a reply. In that cases, this is my remote PC MAC address. Remote PC MAC address. So not this one. This is my remote PC, that is 183 PC, right? So how to check if config? How to check IP address in a Linux is if config and other things also there. This is the IP address of my remote machine and somewhere MAC address is there. Can you see? This is the MAC address of my remote machine. Yeah, 183. 183 C000C 29BFBCFA. Okay, so this is my remote machine IP address, remote machine MAC address. How I got it? Because of ARP protocol, and it will learn dynamically. It learned dynamically, and you can give statically also. You can assign it statically also. Okay. For example, ARP space slash question mark. Okay, so this is if you want to enter static. For example, you want to design a security. For example, MAC address, IP address of a remote machine matches, accept the packet. Okay, that type of network design also we can do it in security places. Certain security places, what they will do, they will add each device IP address and their MAC address. If both are matches, accept the packet, otherwise drop the packet. Okay, this is commands, ARP commands. Okay, this is for getting display ARP table. This is for adding statically to the. How to do telnet procedure using PuTTY? It's a simple. Go to PuTTY. You need a remote telnet device or a server, and a telnet server IP address. Select telnet option, open, and you give username and password. Okay. This is one more is there. Then we'll complete this one and we'll go to the next topic. Yeah, guys, always there is a comparison between OSI model and TCP IP model, and lot of people think from OSI model TCP model is came. No, guys, OSI model and TCP model means original DoD model came earlier than OSI. OSI model is around 80s, but DoD model is almost 67, 70s only. It is a very old model. It's a defense model. Later it is given to the public. Okay, so here it is for only comparison purpose because purely comparable, and we are all using TCP IP model only, not OSI model. That's why compulsory we should know the comparison. In TCP IP application layer do 3 layer job: application, presentation, session layers of OSI model. In TCP IP suite model, Its transport layer do duty of transport layer of OSI model only. Internet layer is do the network layer duty. Network access layer do data link and physical layer. Okay, so here we have a 7 layers, there we have a 4 layers. Application presentation session 3 layers combinedly one single layer called application layer. Transport layer is transport layer, network layer become internet layer, data link layer, physical layer combinedly network access layer. You may get doubts. I told hub, switches, routers kind of stuff, but we have NIC, LAN card, Ethernet card, which layer it is. So NIC is a physical connectivity. NIC, physical type of connectivity. Okay. And NIC also having MAC address. So which layer? Layer 1 or layer 2? So that's why it is TCP IP network access layer, which is combination of physical and data link layer. Okay, guys. Okay with your OSI model?
Yes, sir.
Okay.
Yes, sir.
What is OSI? Open System Interconnect. It contains 7 layers. It is a reference model. It is a network model or networking model to understand how network is working, to create a new network, to troubleshoot a network and maintain the network. This OSI model is useful. It contains 7 layers: application, presentation, session, transport, network, data link, and physical layer. Okay, so and here it is certain protocols. Protocols are used to identify what kind of service, what type of communication, or what type of request and response. HTTP, HTTPS is compulsory difference between HTTP and HTTPS. So remember guys, HTTP data is not encrypted, HTTPS data is encrypted. FTP, file transfer protocol, SSH, and TELNET and RDP remote access purpose only. SMTP, POP3, IMAP, there are mail communication related. TFTP for remote configuration, upload, download kind of stuff. DHCP server give IP address to the clients. It is used to assign IP address to the clients automatically. DNS, the DNS server will maps your name to IP addresses. You don't know IP address of a particular server, so you will get an IP address from DNS. Okay, NTP, Kerberos, LDAP, SMTP, like these are the certain protocols. Application layer with the application part of your network communication, client side, server side application protocols. Presentation layer, encoding, decoding, compress, decompress, encrypt, de-encrypt. Session layer will maintain the session, create a session, terminate the session. Okay, so it maintains the session ID, it will manage connectivity, authentication, authorization kind of stuff. Authenticate the connection request. Transport is providing end-to-end connectivity and transport layer do segmenting, numbering, sequencing, and the transport layer also do error correction, part of OSI model, providing end-to-end connectivity, and multiplex, demultiplex of TCP and UDP type protocols. It also do flow control or windowing. Okay, and there is a TCP header is added to your video, your data, that is called segment. This segment send your network layer. So network layer added a source IP address and destination IP address to your segment, that is called packet. The packet sent to the data link layer, there it is added with the source MAC address, destination MAC address, and CRC. That's we call it as a frame. And error checking or error detection will happen at the data link layer. And physical layer, the frame received and converted into bit stream, and bit stream converted into different form of signals like a electrical signal or a radio wave signal or light wave signal. Okay, so this is your OSI model. Now take a break, guys, and we'll see what topic we want to start. Maybe either troubleshooting of network related issues or maybe new topic. UDP port number is 7, I think so. TCP, UDP also having port numbers, guys. But usually TCP type protocol, UDP type protocols are there. But you can go to protocol list, there we will find. Try anything. So take a break. We have 15 minutes.